Hello everyone, Jonas here, also known as Forces. And this is my first YouTube video about SuperCollider. And I want to do this video to explain my own version of frequency modulation synthesis. And this is because I recently had a new record called Permutations, which was released a couple of months ago, last May. And it was released on Biodiversity Records, who are based in Florence, Italy. And you can go to their Bandcamp page to listen to the album and even buy it if you want. And the whole theme of the record is actually this frequency modulation synthesis. So each of the tracks has some relation to this synthesis method. And I try to explain it a bit more in detail now. So if you don't know, the digital frequency modulation synthesis was invented by John Chowning in late 60s and early 70s at Stanford University. And a bit later, Stanford University sold the patent to Yamaha Corporation. And Yamaha made in the 80s a whole series of FM synthesizers. And the most famous of these are the DX7 synthesizer, which was at some point the most sold synthesizer ever. I'm not really sure if that's the case anymore. So basically, if you're listening to, let's say, 80s pop music, you're quite often listening to the sounds of DX7. And I feel that there's something kind of magical about FM synthesis. It's kind of, in a way, it's like conceptually, it's quite simple. Different sine wave oscillators modulating each other in series or parallel ways, and then but the sounds that you get from this method is kind of incredible. So like whole world of alien tonalities and metallic sounds, and I wanted to make like a whole record just trying to do different kind of FM sounds. Some of them are made with VSTs, but quite many of them are also my own implementations of FM synthesis. And now I will actually show one implementation, which is kind of directly inspired by the DX7. So let's go to MS Paint. And here we have 32 different algorithms. And these are the DX7 sine wave kind of configurations. So these different models you can, I think, select from the DX7. And these are like, this diagram shows how the sine wave oscillators, how they are modulating each other. So if you check the last one, it has 6 oscillators and they are in series. So the first, second, and third, and so on. It's just outputting that sine wave oscillator. But the third one is actually feedbacking itself. So the output goes back to the input of the, I guess, frequency input of the 6th oscillator. And actually, I should say now that I know that the DX7 is actually in a way, it's a phase modulating synthesizer. So the modulation happens in the phase. But that's kind of a technical discussion. And for my version, I wanted to actually to modulate the frequencies of these oscillators. And the version that I will show will be the second oscillator. No, not oscillator, the algorithm. So this, I will show my implementation, how I made this, that the second oscillator is feedbacking to itself, and that goes to the first oscillator. That's just one first block of oscillators, and the fourth, third, fourth, fifth, and sixth oscillators are in this different block here. So the sixth modulates the fifth, and the fifth the fourth, and so on. So yeah, let's go to SuperCollider. And this is kind of a also more technical thing, but SuperCollider, whenever you usually use it, you are operating with this block size of 64. And that's kind of bad for the feedbacking thing, because that usually you would need a single sample feedbacking system. And there you could change the block size to 1, but that sometimes also can produce some glitches and stuff from the SuperCollider if your SynthDef is too complex. So I want to show you a method I found out using this demand UGens. So basically, first you need this buffer the size of 1, and then we can actually go to this do the demand UGens help file. Oh yeah, I was there already. But yeah, in the end, it actually has an example of this single sample feedback by using this debuff read and debuff write together with the duty thing to get this output of this write and read feedbacking system. So basically, I implemented this as my oscillator feedback here. So it's reading from the buffer, and the buffer goes. The buffer is basically the feedbacking system, and it goes to the frequency argument of the sine oscillator, and then you'd retrieve it from here, and it goes to the first oscillator as a you add it to the frequency here. And this example that I'm showing, usually the DX7, I think it has a lot of envelopes for the modulation values. But for this case, or for my own synthesis, I had only one modulating envelope here. So it's not super complex, but you still get like nice tonalities from just this one envelope. And then we have just the amplitude envelopes here. And here's the second block oscillators. So now these are actually in different order. So this would be the 6th, 5th, and 4th, and 3rd, but they are in actually different order. That's just like kind of normal. It goes to this, you add it here, and you have the envelopes. So this is already at GitHub, so you can download it and then just try it out in SuperCollider, and you can change different values. But I will show now how I've been making these examples with different patterns, just like kind of simple examples. So I evaluate that one. And the first pattern has just like everything, all the values is 1. So, and the frequencies here are just MIDI notes. So nothing special, should be quite boring. You can listen to it. So you have a bit metallic sound, but it's very boring. So let's add a bit more modulation. So here we have the index values have p whites, so constantly random values. And oh yeah, seems to have a splay here. Did I have a splay? Yeah, there's a splay. Yeah, so listen to this one, and the ratios are now all over the place already. Yeah, maybe a bit more interesting. The metallics tonality really you start to hear it. But let's make it even more complex. Now we will have PV rand for duration values. The frec values are still kind of the same, and then P rand for ratio 1, and then the indexes are P whites and a bit more randoms in the envelopes as well. Oh yeah, it's clicking a bit, but yeah. Anyways, you hear a bit more interesting. So, what about more like droney FM synthesis sound? So here we have a duration value of 10. So this would be very slow. Yeah, quite nice. And I think yeah, I seem to have like all the rands are 1, 3, 5. So yeah, not so much randomness, but because it's in each different values, so it makes quite complex sounds already. And here I seem to have like more like just like different kind of, oh yeah, I have a P series in different places and P whites, but otherwise actually it's not super complex. Let's see how this sounds. Yeah, I think this is cool. And here I'm just a bit more like a funnier computer music example. Yeah, proper computer music there. And here, the last example of this patterns is more like a acid synthesizer, like 303. Well, it's not a 303 at all, but FM 303. Not perfect in enemies, but you could like maybe achieve some kind of acid sound with this kind of my SynthDef. But yeah, this is already in GitHub, so you can try it out. Just download it. And lastly, I will show you actually um, a more messier code. So this is actually from the uh, record code. So I was using this part of for making one of the tracks. The track was called Filter Moisture. And yeah, we can listen. It has a bit, it's not cleaned, so it has like, here has some random values, and then yeah, different kind of random values. And I don't know if the envelopes might be different as well, but in general, the synthesis should be the same than this previously example here in the code up there. But we can listen to this one. Something like that. I think I was jamming. So when I record the track, so I was changing the values on the fly. So I think I have already lost the end result, but how I actually recorded that track for the album. But you can try these codes as well. These are also in the GitHub. But yeah, that's kind of it. So just like a quick presentation of how I made one of the algorithms from this DX7 synthesizer, and how I implemented in SuperCollider. And I don't know, hopefully this was somehow interesting, or I don't know, you could try it out for making noises. And you can always reach me out if you have any questions in different places. You should be able to find me easily. That's it. Bye.